Hello friends, I'm Snigdha Kakkar and this is my YouTube channel Accelerate AI Careers. So this is the third chapter to my playlist for generative AI and first chapter to my playlist for natural language processing. This is targeted to help you start at a beginner level and become acquainted with the theoretical as well as practical concepts in this field of generative AI. We'll also do hands-on projects in parallel that will help you learn more in depth and become an expert. In this particular session, I'm going to go over basics of natural language processing, the roadmap you should follow to become an expert in NLP, as that would help you learn and apply your knowledge in generative AI. This is quite essential to form a strong foundation and understanding of generative AI models. If you feel that you are already sound in this domain and do not need a quick recap of NLP fundamentals, I would advise you to skip this chapter and move to the next chapters in the playlist. But if you believe that you need to clear out your basics and essentials for natural language processing, then stick with me to the very end of this video as I bring you speed to the NLP. Now, if you like my sessions, please like this video, subscribe to my channel. If you feel that I should prioritize some other essential topic in this field, please mention it in the comments below. So let's begin our learning journey today. To begin with, in machine learning, we solve two problems primarily: supervised learning, unsupervised learning. In machine learning, majority of supervised learning problems, we basically solve two subcategory of problems: classification, where the output variable or dependent variables are discrete, and the second is regression, where the output variables are continuous. Supervised learning basically implies that you have a labeled data set, that is, you have a set of independent variables or features, corresponding to which you have a dependent variable or output. Our main aim here is to create and customize a model trained on specific labeled dataset, and then our model will be able to make predictions on unseen dataset. Now, some of these independent variables could be completely text, could be, partially text, such as in a spam classifier. The output there would be whether the email is a spam or not. The input features could be email body, email to, email from, or email subject, priority, and so on. All these are text features. Now, how would you classify a particular email as spam or not a spam? If the entire data is text and not numeric or categorical, how will the model understand this? Model is not directly capable of understanding natural language, the human language. Now, to add to this the complexity, today the email is in English, but the next email could be in Chinese, could be in Spanish. Then how would the model classify such a text if it is not able to interpret or understand natural language? That is where natural language processing comes into picture, and it is a big part of machine learning and deep learning techniques and now generative AI techniques. We have techniques used in which we convert these text inputs to meaningful vectors. This will help the model to understand the data input stresses on meaningful vectors. Why is NLP important to understand and study is we have a plethora of applications running on NLP around us, such as Amazon Alexa, Google Nest, recommendation search engines in all of the platforms you use daily, such as Netflix, Amazon Prime, and now large language models as well. So let's look at the basic roadmap we are going to follow in this NLP playlist, which is a subset of generative AI playlist. And if you feel that you are confident in all of these skills, feel free to skip the video. So the roadmap which I'm going to follow is as follows. You should first formulate a strong basis in Python. There is no substitute for coding, of course. Now, on all the basis of Python rests the first step, which is text preprocessing. The simple text preprocessing techniques start with the fundamental ones, such as tokenization, which involves breaking the paragraph into sentences, sentence into words, and so on. Lemmatization, stemming, stop words. This is a very high-level roadmap, so it doesn't list out all the techniques, but just a very high level. When I delve deeper into it, I will be touching more of the techniques. Now, when we increase the complexity of text preprocessing, then comes the second step, which is bag of words, TF-IDF, Unigrams, Bigrams, and so on. And these are all techniques which are basically aiming as generating a clean input, converting our input text to vectors. Now, even more complex techniques lead to step 3, which is word-to-vec, average word-to-vec. These again aim at inputting text to vectors, converting the text basically to vectors, And also they work better than step 2 techniques or step 1 techniques. So as we go higher up in this, the complexity increases, the performance increases, as well as the size of model also will increase. Now step 4 is the deep learning technique, which is recurrent neural networks, LSTM recurrent neural networks, GRURNNs. These models are essential to understand natural language processing. Now, step 5 is word embedding techniques. There are a lot of techniques under word embedding umbrella, which we will touch upon here. Step 6 is complex machine learning models that involves transformers, BERT, a very important concept called attention, self-attention, and we will be addressing each of these. And finally, step 7, which formulates the basis for all of the text models in generative AI large language models. So we'll be starting with the very basic building block of NLP and reaching the final block of generative AI, which is large language models. I hope this roadmap works for you. Let me know in comments if you prefer some different style of teaching. Now, let's touch upon some of the practical use cases of natural language processing, which you use day in, day out, but do not realize that you are using natural language processing. I'll actually touch base each of these use cases right now and explain you how it works on NLP. And once we are done till the 7th step, which is large language models, we will try to replicate them hands-on and do small projects on each of these segments. So the first use case which you see is grammatical corrections, such as used by tool like Grammarly or built-in tools in MS Word. Sentence completion, which when you press tab and a sentence completion advice comes to you whether you want to accept it or not. So that is a very big example of natural language processing. The second example is recommendation engines. So based on what kind of things you have viewed in the past or what kind of things your friends or friends of friends have viewed, these recommendation engines recommend you certain content to watch or read, such as on Kindle or Netflix. So it is exactly running on NLP again. The third is language translation. Whosoever has traveled understands that they cannot learn all the languages. So they use Google Translate or DeepL Translate frequently to do translations. Again, a natural language processing application. Then text summarization. Many a times we go through big manuscripts and we usually use a summarizing tool or an application to summarize and generate a synopsis. Again, an NLP application. Then text classification. Good example would be news categorization or news classification. Again, NLP. Now, conversational bot, which is hitting the market to a large extent since generative AI came into being. A lot of people are using retriever augmented generation to make question and answering platforms, llama indexing to make conversational bots, intelligent bots. So that is also an application of NLP, which we will be replicating, which we will be making from scratch and deploying it. Now, the next is search engine. So Azure AI search, Google search, all are examples of NLP techniques again. Text to image conversion and recognition. So say suppose I type Snigdha Kakkad on Google and hit enter. So it not only generates the top 10, top 20 results matching with my name description, but it also finds all the images and all the videos matching my description, which might have those hashtags or which might be related to some or the other way to an account which is named as Snigdha Kakkad. So that is again an application of NLP wherein it recognizes the text, relates it to an image, or reproduces the results. So text to image conversion recognition, text to video generation and recognition, and then finally text to audio generation and recognition. So in today's world, smart homes is not a rare thing to see. And many of the tools used in smart homes such as Amazon Alexa, Google Nest, Google Assistant, all these things basically use audio to text and text to audio conversion and recognition. So that is again an application of NLP. Now, a very good application of large language models is coming into picture, which is text to code generation and text to SQL generation, which will basically help as an assistant to a software developer to code or to a non-software developer to generate code or SQL queries. So these all are applications which we will look into or touch base once we have gone through the basics of NLP. So stick around. watch the other videos for NLP if you like to do these practical applications later on. I promise that will not be a waste of your time. And let me know in comments if you would like me to follow a different kind of approach towards generative AI. And if you like my lessons, please like my video, subscribe to my channel. If you feel that I should prioritize some other topic, mention them in the comments. Let us bring this learning journey on. Thank you.